Hello, everybody, and welcome to the Innovation Spotlight '04. We're going to be joined by the European Space Agency for this particular session. I think we can kind of get into it. I'm joined today by Rich Cockle, who's my boss. Rich, do you want to say a few words? You're on mute. We've got to get that one sorted.
Yeah, every single time, isn't it? Hey, game when I can actually finally get that one right. So Faye's really super excited about today's session. We're doing a lot of work with the European Space Agency. It will be really good to share what we're doing at the GSMA, but then obviously hear a lot of the thoughts of Antonio about where this might go. I have a feeling that this session might be out of this world. But
Love it. Okay, let's get Antonio in on the session, and then we can get into it. Antonio, a man, myth, legend in the space game. Who are you, and what do you do?
Good morning, Fez. You're too kind. Good morning, Fez, Rich, and good morning or good afternoon, everybody listening from wherever you are. So I'm Antonio. My name is Antonio Franchi. I'm a husband, first of all. I'm a father of 3 children, and I also work at the European Space Agency. I'm based in the UK office. The UK office is called EXAT, which stands for European Centre for Satellite Applications and Telecommunications. So as the name says, it's very much focused on space application and telecommunications. So my specialty or my focus is telecommunications. And at ESA, I had the Non-Terrestrial Network Program Office.
Cool. Now, for those of you that don't know what exactly the European Space Agency is, we hear a lot about NASA as being one of the big space-based organizations. How is ESA different to NASA? Both are space agencies, but maybe you can talk a little bit to what's the difference between the two.
Good question, Faisal. Thank you. ESA and NASA are kind of sister agency in a way. NASA is the agency for Americas, and ESA is the innovation agency for Europe. So what we do is we promote innovation, R&D technologies for all space specialties in Europe. So we work with European industries and European member states mainly, but also other non-European, like Canada, for example. At ESA, we manage roughly 7 billion euros a year. So our yearly budget in 2023 was 7 billion euros. So we manage 7 billion euros in space innovation, space technology on behalf of our 22 European member states. So in other words, each ESA member states empower us and fund us in order to promote collectively the R&D, space R&D technology in Europe. Of these 7 billion euros, roughly 10%, about 700 million, are focused on space telecommunications, satellite telecommunications. Of course, at ESA, we deal with innovation across all space sciences. So we have space missions. We deal with human and robotic exploration. So we send astronauts to space. We send rockets to space. We promote exploration of the solar system, planetary system. One of the projects we have in telecom actually is to go to the moon very soon, together with NASA and our colleagues. And we do a number of space missions. So far, we have counted roughly more than 120 space missions, which involve launching objects in space in the planetary system somewhere around the planet. And so that's what ESA is. We collaborate obviously with NASA and many or most space agencies around the world. We conduct joint mission or perhaps individual mission. But the main responsibility or remit for ESA is to promote the space competitiveness of Europe and European industry in particular.
That sounds absolutely fascinating. That sounds really fascinating. But maybe non-terrestrial network, that might be something that we probably need to describe as well, because, it's something that we're going to talk about a lot. But, is there a way that you want to try and describe it, Antonio, just for everybody that's listening? And then we can maybe start to explore the intersection and collaboration points with mobile.
Yeah, thank you, Rich. That's a good question, because the word non-terrestrial network is something that seemed to have recently appeared in the large mass of people. Everybody talks about non-terrestrial network today, but we need to think about the satellite. The satellite communication has been existing for many, many years, decades, in fact, and the planet and the benefit from satellite communication for the last 50 plus years. Recently, though, there have been a couple of triggers for innovation and convergence between what we call terrestrial networks, which are typically cellular networks, fiber optics networks, together with satellite networks. And that came about to start talking about terrestrial and non-terrestrial networks. Basically, in the last, perhaps, decade, with the progressive digitalization of industry and society, the need for connectivity are becoming more and more stringent and demanding. So the continuous digitalization of industry and the so-called Internet of Things, or previously machine-to-machine communication, now called Internet of Things, require connectivity everywhere, requires seamless connectivity. And that's where the convergence that's where space become an asset to provide this seamless, ubiquitous connectivity. That's where non-terrestrial network can help to augment coverage of terrestrial network and complement coverage on terrestrial network. So while effectively the two sciences come from two different points of views and typically dealing with different sector of the industry, recently this convergence calls for a rethinking of the entire industry value chain, as well as the industry positioning, in order to provide seamless network, converged networks. And that's when non-terrestrial network become very, very important. The other aspect which is coming about is that the increase in technology and the increase of mass market development from space allow the cost to be significantly reduced as well. Satellite used to be something for very, very specialized premium type of market to provide communication for very, very special sectors. Now, these days, with everyone, both industry and society requires continuous coverage. And the decrease of cost of providing satellite communication allows the convergence of the network. Perhaps the third and last fundamental enabler or trigger is the coming of the so-called mega constellation or constellation of satellites in low Earth orbit. By reducing the distance where the satellite orbit circle around the Earth, it's possible to reduce the cost, reduce the delay or the latency which the signal to travel to the satellite back, and also reduce, fundamentally important, the size of the terminals which are designed to receive the satellite signal. So the combination of this digitalization of industry, transformation of the space sector thanks to the low Earth orbit constellation satellites, and the price reduction of satellite services make non-terrestrial networks so much more appealing to answer the global demand for connectivity.
Yeah, we keep hearing a new story nearly every day, don't we, in terms of how that connectivity story is building up with the work which T-Mobile is doing in North America. And then obviously we're starting to see the first direct-to-device connectivity solutions for IoT. So, you know, it's really becoming a real thing in terms of that connectivity. And I know Faisal and I were really lucky to come down and visit you at your telecoms board recently. And, you know, that's where we discussed the potential for how do we integrate these even further into some of the working practices which mobile operators have already got today, and then how can satellite leverage those. You know, from your perspective, Antonio, how do you see that as a direction of travel? Do you see that closer collaboration between the industries, you know, happening? And I guess, or maybe I'll come back with another. Yeah, you go with that first of all.
Yes, I think it's a very good question. I think you mentioned the second buzzword of the time, which is direct to device. So non-terrestrial network and direct to device are obviously spoken everywhere. And I was lucky enough to be present at your Mobile World Congress 2024 in Barcelona, where direct-to-device and non-terrestrial network was really buzzword for the entire cellular world. Likewise, I was present at the World Space Business Week in Paris, which is one of the most relevant satellite conference of the space sector. And equally there, direct-to-device and non-terrestrial network were really very, very hot topic. So obviously, yes, I think this is fundamentally important that for this convergence to happen, not only the networks need to converge, but the mindset, the business model, the terrestrial infrastructure, the satellite infrastructure, all the business support system elements allowing this seamless interoperability or roaming or transition between terrestrial and non-terrestrial need to happen. For that, obviously, the terrestrial telco or MNOs world and the satellite SNO, satellite network operator world, needs to converge. That is a condition sine qua non, is absolutely a necessary condition for this convergence to happen. There are a few other things which need to happen as well. The entire planet, the entire globe need to abide behind a common global telecommunication standard in order for satellite and terrestrial network to seamless communicate and talk to each other. They need to comply with global standard. In this case, we are big advocate of the terrestrial 3GPP standard, 5G and future 6G. So the convergence of terrestrial and non-terrestrial network is also predicated on global compliance with 3GPP standards. So yes, I think we see all of this happening, and we see the partnership between that you mentioned between mobile network operator and satellite network operator happening all over the world in different shape and format with different type of frequency use, different type of terminal, and different type of interoperability. And in my view, we will see this more and more happening. In fact, in Europe, we are really federating the industry to position ourselves to provide direct-to-device type of offering, which really comply to global standards and provide the seamless connectivity with terrestrial and satellite networks.
Yeah, and I think what's really struck me is part of the journey that we need to go on is aligning these two different sectors to understand each other. And I think, with there's some really, obvious examples of that. But I know we're doing a lot of work with your support inside the GSMA working groups and communities to try to do that. I think there'll be a white paper out later on this year. But what struck me was little things like, when I talk about coverage coming from a terrestrial background and a mobile background, that means one thing. And then obviously when you're talking about coverage, you mean the whole planet. Yeah. So, just making a difference between, understanding when I talk about coverage land, over landmass, and then saying there's 90% coverage. But, to you, that's a completely different use of the same word, which I found fascinating, which I hope we can bridge that.
It is very fascinating. I agree, Richard. I think it is very fascinating. If you think about it, I was interested in reading some of your GSMA intelligence report, which are really, really interesting for us, and talk about perhaps in Europe the lack of 7% of connectivity, if you like, and that talks about population connectivity. We are more focusing on geographic coverage, and for us, geographic coverage meaning covering the entire planet, and the 7% lack of population connectivity for us is one metric. The other interesting metric is that over 70% of the planet is currently not covered by connectivity. So that put things in a very different perspective. For us, the market, the potential and the user requirement is global, and connectivity at sea, in the ocean, for example, for us is extremely important to provide safety and security services at sea, but also commercial services at sea, which will enable markets like the digitalization of the maritime system or the proliferation of maritime autonomous ships, for example, with the increased autonomy across all sectors. For example, just to give an example, it is so important that the connectivity is ubiquitous, is everywhere, and is resilient enough to provide service, whether we're talking about connecting an autonomous ship or an autonomous aircraft or drone, or indeed terrestrially an autonomous vehicle or car, connectivity for autonomous vehicles. All these require global, resilient, ubiquitous connectivity. And that's what we're talking about. So that's what non-terrestrial network can provide. They can provide this overlay, this complementarity with terrestrial network, which will cover perhaps the small gap into the population coverage, but most importantly, provide the global fabric, global connectivity fabric, and the resiliency required to allow all kind of new and emerging services and applications.
So we've just had our first audience question. Faye, should we take that now, or do you want to take that afterwards? But it was a great segue for me to say to everybody, if you've got any questions for Antonio, I'm sure you're finding it as fascinating as I am. Just put them into the chat, and then we'll put Antonio on the spot. Faye, back to you.
Thanks. Thanks, Rich. We'll take questions as they come through. Just we've got to be conscious of time, so we'll take this one just because it's so relevant. Telecommunications are essential for all countries. However, 3GPP, non-terrestrial networks, and direct-to-device solutions currently seem targeted at specific niches due to pricing and complexity. When can we expect widespread availability of these services and affordable prices for regular users?
Yeah, this is a very good question. It's a very interesting question, the convergence between technology, adoption of global standards, and indeed price to the user. Eventually, the user is interested in two things. One, he wants to be connected everywhere, and two, he wants to pay a fair price. The adoption of global standards, in our view, is essential to allow lock-in solution where a user gets locked in into proprietary solution. The adoption of global standards allow fair competition on one hand, and on the other hand, allow the creation of economies of scale where terminal manufacturer, chipset manufacturer, or indeed the telco industry in general, whether terrestrial or satellite, can develop solution in a mass market way, reaching many more customers than they usually would do. Typically, the satellite users are a fraction of the terrestrial, of course, mobile network operator users. So for satellite to adopt global standards, allow satellite company or industry to make use of the huge amount of R&D spent terrestrially. So in our view, adoption of standards not only allow interoperability and avoid lock-ins into specific services, but also in the medium and long term allow reduction of terminal prices, adoption of implementation from large standard. We are talking about the large network provider like the Ericsson, the Nokia of this world, and the Huawei and the Qualcomm for chipsets. So we are talking about large, very large global player implementing global standards, which include an element of non-terrestrial network. So imagine, for example, if every phone would also implement by default, by standard, the new radio non-terrestrial network interface, which is a global 3GPP standard. That would immediately reduce the price of implementation of a satellite-specific terminals by several orders of magnitude. And that's what we are advocating. We are advocating one global standards, both for terrestrial and non-terrestrial networks.
Yeah. And I think as the technology matures, that's going to be the challenge. I know that in certainly in some of the working groups, terminal steering group that we've got, and indeed our IoT community, they're both looking at this convergence with NTN and how we can provide guidelines and recommendations in for the standardization side of things. Mm-hmm. That wasn't actually the question that I was supposed to be reading out. So the one that was is there an estimated time frame around the availability of the 3GPP non-terrestrial networks devices and direct-to-device applications?
Yeah, we're following very closely the 3GPP standardization. As you probably audience know, since release 17 from the 3GPP, that's where the first release of convergence between satellite and terrestrial. So that's where satellite becomes part of the 3GPP standard. And in the next releases, 18 and 19, there are more and more features and more frequencies which are going to be incorporated into the standard. Obviously, as the standards become available, ratified, frozen, and then released, then vendors start implementing their implementation of the standards and their interoperability and compliance with the standards. So we expect effectively that they already have several R&D implementation of non-terrestrial network air interfaces. So we see progressively vendors implementing NTN specific solution. In the meantime, we see also the interoperability of pre-standard releases or perhaps non-standard releases that would start the convergence, and then the new release will come available. So we think in the next couple of years, all of this should stabilize, and chipset and terminal availability and satellites will be built, which are standard by design, standard by default. For example, we at the European Space Agency are already supporting the launch of experimental missions with satellites flying 5G technology on board. So effectively, we put a base station, 5G base station on board the satellite to allow even a better network topology or network integration between terrestrial and non-terrestrial networks. There was a very interesting, if I can, phase. There was the very first question which we skipped. It's about NTN specific community. Maybe we want to quickly mention that the work we do together, actually, GSMA has launched a very interesting NTN community to precisely allow this interaction between terrestrial operator and satellite operator and industry manufacturers to get together to define the requirements, to define the test, to define the focus where the standard should go. That's a very, very important. ESA is very happy and very proud to support the GSMA NTN community, which enables the convergence, enable the dialogue on the same table between terrestrial and non-terrestrial network. Equally, ESA is also very involved in that. We have set up an NTN forum, which is complementary to the NTN community. And again, the idea is to allow this dialogue, global dialogue, around standards, about requirements, and about what's needed to implement this seamless network as soon as possible, reduce cost by funding some of the R&D. That's where ESA, one of the objectives of ESA is to reduce the user cost by funding, providing financial support to implement the standard, to retire the risks of implementation, and to facilitate the initial interaction. And Rich, perhaps if I may, you were picking up on a collaboration GSMA ESA. Indeed, we are very, very happy about our partnership and some of the challenges that we launched together, precisely to allow the implementation of solutions that we can test together. And I think we launched two challenges at the Mobile World Congress 2024. And the challenges were one on the user side and one on the network side. We want to promote the convergence of the networks, but also the availability of common user terminals, terrestrial and non-terrestrial. And I think these challenges are always open. ESA is open to fund innovation, not only from financial point of view, but also provide technical and regulatory support for these solutions to emerge as soon as possible.
Yeah, and I'm really glad that you raised that. And I think if there's anybody interested in what you just heard from Antonio about those challenges, just go to the GSMA website and you'll be able to find all the details around it. We've had a great response to those challenges which we set. And I know that we have a number of projects which are moving through the process now towards getting that funding. So by the time we get to Mobile World Congress 25, I'm really excited about hopefully what we'll be able to share in terms of what we've done to stimulate a load of work in that space.
Yeah, for sure. And similarly on the community side of things, as we say, we've been talking about convergence. bring the mobile network operators together, bring the satellite network operators together, and everybody who exists in the ecosystem around it, and bring that conversation together to make it happen. And we've got an NTN community that we spun up, and Antonio mentioned on their side they've got the NTN forum as well. This is about ensuring that we're bringing the communities together and making sure that we're working not cross purposes, but kind of like shaping the vision of the future together. So that's really, really important. Antonio, you touched on obviously the funding opportunities there, and Rich kind of touched on that. Maybe you can get into a little bit more detail around the two challenges that we kind of offered. You mentioned one's on the user side, one's on the network side. Can you share a little bit more around what they're driving to progress in the convergence space?
Yeah, sure. Thank you, Faith. Yes, absolutely. So one of the main, as I was mentioned before, the European Space Agency is supposed to fund innovation. And we support many projects across the entire range, from system definition to initial technical development, to productization, and to test and even field trials and pre-commercial deployments. In terms of terrestrial and non-terrestrial network, we like to promote project and support project which involves an element of terrestrial and an element of non-terrestrial network, and also actors, for example, a mobile network operator and the satellite network operator, interested in developing solutions together, commercial solutions, which make use of a converged network. So in this context, we started our collaboration with GSMA. We were happy to launch two specific challenges. One challenge is regarding the user side. So on the mobility side, one of the biggest topics for the target market for terrestrial and non-terrestrial network is the mobility market. Mobility market for us means mobility across all domains. Start with land mobility. So we're talking about automotive. Automotive is perhaps the biggest opportunity for the terrestrial and non-terrestrial network. And the reason is very simple. Cars are, everyone these days produce connected cars. Every car is connected, needs connectivity for a number of reasons, which range from predictive maintenance, insurance, safety, security, software upgrades, and even, of course, passenger connectivity as well. Another big market is I mentioned the maritime market, both for the ship connectivity, but also passenger. And as we observe more and more services move from ship to shore, the need for connectivity and security is even more stringent. And of course, drones and UAV goes the same. So one of the first challenge we launched is provision of solutions, development of user terminal or applications which enable one of these mobility markets, with a special focus on automotive. Automotive, because we have a collaboration with for example, the 5G Automotive Association, which has asked ESA to provide solutions for global seamless connectivity. The car of the future demands global, seamless, and resilient connectivity to enable all the future services with automotive promises. So that's the first challenge we launched: develop solution, antennas for cars, integration between the car onboard electronics and terrestrial, non-terrestrial radio connectivity, or even an end-to-end service in the automotive market, which make use of non-terrestrial networks. So that's the first challenge. And the second challenge, following the great success of the Open Gateway GSMA program, which aims at developing common APIs, interfaces, and services across multiple operators, we want to extend that to non-terrestrial network and non-terrestrial network operators. So the second challenge is on the network side, to make sure that today's network and tomorrow's networks includes seamless connectivity between terrestrial and non-terrestrial network. And the Open Gateway API are extended or complemented or integrated with new existing or new functions specifically to focus on to non-terrestrial network. It can be roaming, can be services across the various terrestrial, non-terrestrial network, and anything generally facilitating the integration and the seamless experience for the end users. So these are the two challenges we launched. One on the user side, automotive connectivity on the car, solution for the cars, and the other one on the open gateway for NTN specific. The challenges are open. They are published on the GSMA website. Obviously, we work together with GSMA and ESA to respond to any expression of interest which we receive through the GSMA portal. And then we at ESA, we will guide the consortium, the industry, through the ESA process in order to apply for funding, clarify the scope of the project, and liaise with the relative member state delegation where the company actually reside. As in ESA, we operate on a geo-return basis, which means that we manage funds on behalf of each European member states of ESA. So we work with the local space agency to facilitate the local return to the industry which apply.
And I think this is kind of like the bridge in the community, in the sense that community, we come out with projects, and part of the challenge that we have in the telco industry is around the funding of those projects. So it's almost like we bridge that with the ESA funding to enable those pilots, POCs, those demonstrations to take place around this convergence piece. And that's one of the key kind of pieces of the puzzle when we did the partnership with the European Space Agency, is how can we help foster, how can we help, drive innovation in this area, and, really looking forward to seeing those results coming out. I'm conscious of time, so what we'll do, we got an Ask Me Anything question, so question session that will come up, so feel free to drop any more questions into the chat. We saw at the weekend, obviously, SpaceX catching the rocket booster. When I saw it, I was actually thinking, this is fake, this is reversed, like this can't be real. And then you go back and you watch it and you, wow, it is something. The economics in space has obviously changed significantly. Low Earth orbits, constellations are getting deployed, and we're seeing more and more partnerships, something evidenced through the GSMA Intelligence Non-Terrestrial Networks tracker that we've got, which is basically tracking all of the deals and all of the partnerships that are taking place. How do you see kind of like this space evolving in the future? We talk about 5G, we talk about 6G. How do you see it unfolding, and where we're going in the next, sort of like 5 or 10 years?
Thank you, Faisal. Yeah, yes, absolutely. We saw it over the weekend. Fascinating, the SpaceX return. And that is all real. That is all absolute reality, and it gives you a glimpse into the future of space. There is fantastic technology, amazing progress happening across the space industry, which makes it really, really interesting. And you can only imagine the future services. One thing is clear: the space and the application offered by space, which are typically the telecommunication, navigation, and Earth observation, are already used today in many form and shape. Every car has got the GPS receiver, and every app tracks receives satellite positioning, for example. That always happen. And a number of Earth observation satellites, they continuously observe the Earth by monitoring things like climate change and protecting or detecting fires, for example, in areas which would be impossible to detect from Earth. So all of this is already happening, but the convergence and the accessibility of space services is what will make the future so much more appealing. The many satellite constellation being launched. Before we were talking about tens of satellites in orbit, then 100. Now we're talking about tens of thousands of satellites in orbit. Will massively drive the cost down and open up a whole new services. You mentioned the 3GPP, 5G, and 6G. The 5G standardization itself foresees this convergence, and that there are new services which we start looking towards in 6G, which is called joint communication and sensing. That's where the two sciences of telecommunication and sensing, so network sensing, gets together. So the networks are used not only to communicate, but also to monitor the environment, to sense what's happening. And if you project that in space, you can think that you can project that at the global scale. So imagine a satellite constellation which can simultaneously allow people to be connected everywhere, but also monitoring what's happening on the planet and being able to react in real time to prevent disasters or to respond to emergencies, just because the satellite and the intelligence built into the satellite can automatically make decisions in the future where it could detect the potential problems and react by deploying, for example, resources or emergency services if required to prevent a big disaster to happen. So I think the future is fascinating, and without the convergence of space and terrestrial network, we cannot see this happening. So we foresee a big step up in use of space in normal life for normal people, but also for industry and digitalization of industry, as I mentioned before, and many exciting services which will be enabled thanks to this global connectivity of the future.
Yeah, that's absolutely fascinating. Just moving gear a little bit and just maybe, talking about a topic which is, of a lot of interest within our terrestrial ecosystem, but, sustainability. The sustainability is going to be key. We've talked about the economics of it, but obviously we hear a lot about, the debris, which we're now starting to hear a lot about that, and, satellites. I know ESA have got quite a focus on this. Maybe you could just share what ESA's doing around that problem, so it's not, accelerated through our desire to get more coverage.
Yeah, absolutely. This is a very, very serious, very, very important topic, Rich. I'm very happy you brought it up. We are very, very conscious, and we're very, very keen in making sure that sustainability is at the forefront of everything ESA does, and in fact, everything we do in the planet in general. We like to talk about two types of sustainability. We like to talk about sustainability in space and sustainability from space. And I'll quickly explain the difference. So sustainability in space is to make sure that every satellite we put in space doesn't pollute the space itself. So that there are sufficient provision in the design of the satellite, the demise of a satellite. So in other words, how do you decommission a satellite and you allow to self-destroy as re-entering in the atmosphere in order not to pollute, not to produce debris. We are promoting global standard in this respect as well. And in fact, every single mission, every single satellite ESA supports by to very, very stringent zero debris policy, which would promote a safe, clean space to be maintained. So that's what we call the sustainability in space. Every object we put in space, or everyone put in space, should have comply with global standards to maintain sustainability. Obviously, the other big advantages satellite brings is sustainability from space. And I was referring before, the use of satellite to detect climate change, for example. The use of satellite to detect man-made disasters like leakages or oil leakages or CO2 leakages, or monitoring of the CO2 environment thanks to satellite, or even optimizing, for example, the airline routes by in order to minimize distances and reduce the CO2 emission. So that's positive contribution. Sustainability from space is the use of space, the use of satellite to monitor, to prevent, or to react to potential threats or sustainability threats. So that's a positive contribution that satellite brings. Together, as I mentioned, European Space Agency, we are focusing on both the sustainability from space, in space, to reduce debris and potential collision in space, but also very much sustainability from space, how the building of space networks, terrestrial network, and any type of networks are built with sustainability criteria in mind, and space is used to minimize potential threats, man-made or natural-made, which would potentially compromise the sustainability of the planet.
That's really good to hear.
Cool. Thanks very much, Antonio. We could talk about this subject for hours. I've skipped on so many questions, to be honest with you. But like we're heading towards that ask me anything question. As I mentioned in the chat, feel free to put your questions through, and then we'll take them through to Antonio. Anything that we can't answer, we'll try and get offline as well. A question coming in from the chat. Which of the ESA-funded NTN activities will be demonstrated at MWC 2025? I just want to quickly, before we jump into that one, just do a quick shameless plug. We've got our Foundry Excellence Awards, which has an NTN category. So if you do have any NTN-related projects and you're interested in applying, do submit those in. But I think we haven't quite made a decision on what we're going to be demonstrating at MWC Barcelona 2025, but suffice to say, it will be part of that thing. Antonio, I don't know if you want to add anything.
I was just going to say, go on, Antonio. We're talking over each other. Sorry.
No, very quick. I think you can complement it. We don't know yet about 2025. We were present. We are very pleased to be hosted at the GSMA pavilion with GSMA 2024, where we had our small ESA stand. We showed some of the developments, some of the application we did. We had actually a live video conference over an operational constellation of satellites, OneWeb in this case, where we're very lucky to have the King of Spain connected live through the satellite operation, through the non-terrestrial network, to our 5G, 6G hub in the UK, in Harwell, at our satellite application telecommunications center. That's where we have deployed hybrid network, 5G and satellite network with multiple live constellation of satellites. So we had one live connection. We also showed a number of augmented reality, virtual reality, which we didn't have time to talk about today, but we also focused very much on the future and how the convergence of artificial intelligence, non-terrestrial networks, and AR, VR solution will enable future applications. That's something that we work with the GSMA Foundry as well, and it's a future element. So you need to keep an open eye for what happens in MWC 2025. I'm sure we were able to demonstrate some innovation in this area as well. Rich, I think you were saying something.
Yeah, I was just going to compliment what you're saying. I know we haven't quite got the demos nailed down yet, but I know that we do have our Satellite and NTN Summit, which is in the schedule for MWC. I'm not quite sure what day it's on yet, but I expect there to be a packed agenda within the Foundry and GSMA activities and beyond around the satellite and NTN topic at MWC 2025. Shameless plug. Hopefully see you there.
And to add another shameless plug on top, on the GSMA Foundry website, you can find all of the recordings for all of the previous NTN summits. So whether it's Barcelona, Shanghai, or Vegas, you'll be able to get those up on on the website. I am conscious that we're already over time, but there's a tradition that we have in the innovation spotlights where we ask the guest to ask a question to the next guest that will be appearing on the show. And on the last session, we had Luis Ramirez from Mowari. And the question that he posed to you, Antonio, was which technology would the next speaker wish was never created or implemented? I don't know if you have any thoughts on that one.
I think that's one of the toughest questions. If you ask technology, I'm a technologist, I'm a scientist. I like to think I'm a scientist, so I like technology. I think in general, technology is useful for the progress of humankind, and it's very difficult to pinpoint technologies which should not have been invented. Maybe it's more about the use of technology than the technology itself. We can have many examples looking back, but perhaps one thing which we need to be conscious going forward is mass surveillance. I would say mass surveillance, so the potential to observe everyone at any time, like Big Brother kind of thing, is something which scares me a little bit in terms of that technology. although I understand the requirement for security and safety of people, I think the use of that technology opens up a lot of ethical issues and problems. So perhaps mass surveillance is a technology I would question, and I would advocate that better rules should be put in place in order to make use of it. Obviously, it's something which is really required, and it's something that we provide from space as well. Surveillance is fundamental for the security of humankind. But I think it should be carefully applied to strike the good balance between a safe, secure, sustainable planet and right of freedom of humankind as well. Having said that, I think technologies are good for the good of humanity. The use of technology is something I will be conscious and needs to be ratified, especially if you think about artificial intelligence and other new potentially disruptive technologies, which might get out of hand if we don't stay up to speed with the technology itself by building safety infrastructure, ethical and psychological consequences of the use of technology. So I'm not sure I answered specifically the question about. But
no. I like that one. It's very related to the sensing, mass sensing that you mentioned earlier on in the session, the convergence between telecoms and sensing and the two worlds coming together. So we need to make sure we stay on the ethical side of that. Quick question though before we look to close. What question would you pose to our next guest?
Okay, so
it could be anything. Could be life, business, tech related, maybe some advice.
Yes. So I can be the mean one now. Okay, actually, maybe I have two quick questions instead of one, okay. Which I would like an answer. The first one is perhaps looking just the next step. Obviously, is quantum computing, quantum internet. I guess the question for the user would be how would quantum computing or how would quantum internet impact the new technology, the new emerging technology like artificial intelligence and data encryption? I think quantum computing will be the next big disruption in both terrestrial and non-terrestrial network. And the current use of artificial intelligence and also data encryption could change or be compromised by the sheer amount of processing power that quantum internet would allow. So the question, just a generic question, obviously we deal with that already on it every day. We are programmed to deal with that. But how will quantum computing disrupt technologies like AI and data encryption? That would be my question number one. And the question number two is more about the human people. So I'm more conscious and very interested about the potential internet of minds, or people talk about brain-computer interface. Elon Musk talk about Neuralink and Neuralink company. So the question is, what would the internet of mind look like to connect your brain on the internet, share information, access internet directly from your mind, and being able to share with others. So how disruptive would be a brain-computer internet where we would all be connected in the future in a big cloud?
I think we could just dedicate an episode to each one of those questions. We've got a really interesting guest that's going to be coming up on our next session, Marwan Deba, who looks after AI at Khalifa University in the UAE. So we didn't plan it, but those are really great questions that I'm sure you'll be able to hopefully not spend a whole episode addressing, but we'll see where we get to.
She'll be perfect.
All right.
With that.
With that being said, Antonio, it's been a pleasure. Thank you so much for joining us. And as I say, feel free to ask any questions in the chat. We'll follow up after. Thanks very much, all.
Cheers, guys.
Thank you, Rich. Thank you, Faisal. It was really a pleasure. Thanks to GSMA for hosting it. I think it's a very interesting spotlight series, and I will be following and watching the future episodes with great interest. Thank you.
Thanks.
Thanks very much. Cheers.